All right, in Chapter 8, we are going to be looking at how to solve systems of equations. So we're going to review some concepts that you've seen in Algebra 2, and here we go. So the first thing you'll have to do is determine whether each ordered pair that's given is a solution to the system of equations. So this is your system of equations right here. So you have to decide, is each point a solution? And the way you're going to know that is if you plug in the x and the y that's given into the equations and it makes a true mathematical statement. So for instance, for A, if I plug in -1 for x and 2 for y, let's see what happens. So if I have 2 times -1 plus 2, does that equal 5? So 2 times -1 is -2 plus 2, that is not 5. That is 0. That doesn't work. So this is not a solution. A is not a solution. Okay? So then let's try it for B. This is x, this is y. So I would do 2 times 3 minus 5 equals 5. Let's see. No, sorry. 6 minus 5 is 1, and 1 is not equal to 5. So this is not a solution either. And look at C. 4, 4. So 2 times 4 plus 4, does that equal 5? Well, 8 plus 4 is not 5, it's 12. So that's not a solution. So far we don't have any solutions. So then let's try D. So 2 times 2 plus 1 is 5. That checks out. It should equal 5. So now that I know it works in one equation, I have to make sure it works in both equations. So then I try the second one. So I do 3 times 2 minus 2 times 1. And it's supposed to equal 4. Let's see. 3 times 2 is 6, minus 2 is 4. So this is a solution. So this is a solution. Part D is a solution. The rest of them are not solutions. Now, easy enough. Now it says to solve by substitution and verify graphically. So you're going to solve by substitution. And what that means is you're going to take one of these equations and solve it for one of the variables. It doesn't matter which equation you choose. You just pick one. It really honestly doesn't matter. So let's say I choose the second equation right here. And I'm going to take x and I'm going to solve for x. And I simply just going to move that y over and it's going to be y plus 2. So now I take this x equation for x right here and I plug it into the second equation. Instead of x, I replace that x with y plus 2. Y plus 2 plus that original y equals 4. Combine like terms, I get 2y plus 2 is equal to 4. Solve it for y now, and I have 2y equals 2. That means y is 1. All right, great. That means I know y. Now I need to come back and solve for x. Either equation will work. If I take this first one, so I do x plus, now I know y is 1, equals 4. If I solve that, I have x equals 3. So I believe my solution is 3, 1. Now it says to verify graphically. So in order to do that, I'm going to take these two equations and solve them for y and put them in my y equals. If I look at my calculator, I've gone ahead and solved that first one for y. So I just subtract x from both sides and I get negative x plus 4. The second equation, I solve it for y and I ended up with x minus 2. Yeah, x minus 2. So they're in there. Now, graphically, the solution is where the two lines meet. It can happen one time, it can happen 2 times. Or it could happen no times, meaning there's no solution. So I have my equation, the y equals, and let's hit graph. And you can see it clearly intersects right here. Now let's pretend it's really hard to see where that intersection is. Calculator is going to help you. If you hit second and trace, number 5 is the option for intersection. It will find that exact point for you. So you just hit 5 and it'll say first curve, meaning it's on the first line that you put in y1. Hit enter. It'll jump to y2. Just identifying the two lines. Hit enter one more time. It'll say guess. We don't want guess, so we click one more time. And it tells us the intersection is at 3, 1. And sure enough, that is what we got, so we have verified our answer. Yep, we got it right. So let's try another one. So I'm going to pick an equation that has a variable by itself if I can. So I'm going to choose this first equation and solve it for y. So y equals negative 2x plus 5. Now I'm going to take that equation and plug it into the second equation. So I have 3x minus 2, plug in the negative 2x plus 5, equals 4. And now I need to clean it up. So I have 3x plus 4x minus 10 equals 4. So 7x minus 10 equals 4. So 7x equals 14. So that means x is equal to 2. Then I take my original y and I'm going to plug a 2 in there. Figure out what is y. Negative 4 plus 5, so y is equal to 1. So my solution should be 2, 1. So again, I want to graph this. So I've rearranged my first equation, and I need to do a little rearranging on this guy so I can put it in my calculator. So I do that, or divide through negative 2. So y is 3/2 x minus 2. So I need to put those two equations in the calculator. So here you can see my graph, and sure enough at 2, 1 is where it intersects, so I know I have my correct solution. So I box my answer. All right, let's try another one. So on this one, I'm going to use that first equation because it's just 1x and 1y. I'm going to solve it for x. I'm going to show you that it works both ways. If I move that y over, x equals to y, right? X is equal to y. So if I plug that x in my second equation, I get 2y equals 6, so y is equal to 3. Well, if x is equal to y, then my solution is 3, 3. Easy enough. I'll let you graph it to verify, just to save some time. Now on the next one, number 4, I'm looking, okay, what should I solve, what should I isolate to use for substitution? I'm going to use this negative y right here. You could use the positive y down here and you'll get the same answer. It doesn't matter. But I want to isolate it. So I'm going to move that y over. So I'm going to have y equals 2x plus 2, basically. Now I'm going to plug that y into this bottom equation. 4x plus 2x plus 2 minus 5 equals 0. So 6x minus 3 equals 0. 6x equals 3. So x is equal to 1/2. Now to get the y, I'm going to put it in my y equation. 2 times 1/2 plus 2. Well, 2 times 1/2 is 1, plus 2 is 3. So my solution point is 1/2, 3. Okay? All right, let's move on to number 5. Okay, so probably what you notice first is these fractions. So you got to think about, okay, what can I do to get rid of these fractions? Well, least common multiple between 5 and 2 is 10. So if I multiply through this whole thing by 10, what I'm going to end up with is 10/5 would be 2x plus 1/2 is 5y equals 80. So now I have no more fractions. I'm good to go. And I still have x plus y equals 20. That hasn't changed. So then I'm going to actually use this bottom equation because it has coefficients of 1 and solve it for x. So x will be 20 minus y. Now I'm going to plug that into my equation up here. So I have 2 times 20 minus y plus 5y equals 80. And then we solve it. So 40 minus 2y plus 5y equals 80. Clean this up. I'm going to have 3y equals 40. So divide by 3. Y is equal to 40 thirds. Okay? Now, I need to take that 40 thirds and plug it into this equation here to solve for x. So x plus 40 thirds is equal to 20. Well, I want to get rid of the fraction. I'm going to multiply through by 3. So I have 3x plus 40 equals 60. So 3x, if I subtract 40, equals 20. Divide by 3, I get 20 thirds. So my coordinate pair, that is the solution, is 20 thirds and 40/3. Leave it as fractions, do not make them decimals, okay? All right, let's try number 6. So we want to pick something simple, like here's a y that already has a coefficient of 1, so let's start there and solve it for y. This would be negative 3x plus 2. So if I plug this into my equation down here, x cubed minus 2 minus 3x plus 2 equals 0. If I clean that up, I will have x cubed minus 3x. The 2's cancel out. And now I need to clean this up and factor out an x to solve it, x squared minus 3. All right, so remember we separate these out, x equals 0, x squared minus 3 equals 0, x squared equals 3. Take the square root of both sides. Remember we take the absolute value of x is going to be the square root of 3, which means that x can be plus or minus the square root of 3. So, a lot of solutions possible here. We have a solution where x is 0, we have a solution where x is positive square root of 3, and a solution where x is negative square root of 3. So let's first use where x is 0. That means y would be negative 3 times 0 plus 2. So y would be 2. Okay? So I have one solution where x is 0, y is 2. That's one solution. Now, to do the second solution, let's use x's positive square root of 3. That means y is negative 3 times the square root of 3 plus 2, which gives me negative 3 square roots of 3 plus 2. There's not a whole lot more I can do with that, so don't worry about refining that too much. But that makes my solution point the square root of 3, negative 3 square roots of 3 plus 2. All of that business is the y coordinate. Then I need to do, okay, what about x? X is the negative square root of 3. Plug it in, negative 3 times the negative square root of 3 plus 2 gives me a positive square root of 3 plus 2 for my y. So that solution point is negative square root of 3 and then 3 square roots of 3 plus 2. All right? So it is possible when you do systems and equations to have more than one solution. This is a good example of that. Going. Number 7. Okay, let's take that top equation and solve it for y. So x minus y equals negative 2. So negative y equals negative x minus 2. Change all my signs, x plus 2. Now I'm going to plug that into my bottom equation. So x squared minus 2x plus whatever y is. Well, we just said that y is x plus 2 equals 8. Let's clean this up. X squared minus x minus 6 equals 0. Now, it's a square term. I can factor this guy. So the x minus 3, x plus 2. So I know x is positive 3 and x is negative 2. So I'm going to have two solutions, right? So when x is 3, y is going to be 3 plus 2, which is 5. So one solution is 3, 5. Another solution I have is when x is 2, or negative 2. So negative 2 plus 2, that's a 0. So I have another solution where x is negative 2 and y is 0. Okay, so I want to show you how you verify this one verify it graphically. So let's look at that graph. So I want to show you on the graph, if I graph this so that this quadratic right here, that's a parabola. It happens to be opening down, and then this top line is a linear function. So it has two solutions. It has two places they cross. That's why it has two solutions. All right. The previous problem we did, if you'll notice, is cubic. One's a cubic solution. So it's going to cross. It could cross at 3 places, and it does cross at 3 places. All right. Now let's try number 8. Okay. Again, we're going to start with the one that makes the most sense to solve for one of the variables. So in this case, I'm going to solve this bottom one because both terms are to the single power and they have a single coefficient. And I'm going to solve for y, all right? So I'm going to take x minus y equals 2 and solve it for y. So I'm going to do x equals 2 plus y, so y is equal to x minus 2. Now I'm going to take that and plug it into the original equation, or the first equation, I'm sorry. And let's clean it up. 2x squared minus x plus 2. I'm going to bring that 1 over, so minus 1 equals 0. 2x squared minus x plus 1 equals 0. Okay, so, well, this one is not going to factor. It is not going to factor at all. So I got to use a quadratic formula. So negative b plus or minus square root of b squared, so that's 1 minus 4 times a times c over 2 times a, which is 4. 1 plus or minus, that'll be the square root of negative 7 over 4. Well, square root of negative 7 is imaginary, right? That means I have no real solutions here. We have imaginary solutions, or imaginary roots. So I have no real solution. Can that happen? Yes, it can happen, but you really just handle it like a no solution problem. Okay? So we're going to stop here for the first part of 8.1, and then the second part of 8.1 we'll pick up on a different video.